Guys, in this lecture I will discussing about the new theorem of DC circuit that is called the Norton's theorem. It is like the Thevenin's theorem, but the approach is little bit different. It is also used to simplify a circuit and get the current of a circuit in a simple manner, like the Thevenin's theorem. Okay, so let's go to the first question. I'll discuss about the steps of the Norton theorem, how to draw the final equivalent circuit of the Norton's theorem, and how to get the current like the Thevenin's in the Norton's way. Okay, so let's start. Here is the first question. You are given a circuit, okay, and find question number Roman 1. Draw the final equivalent circuit from Norton's theorem. Okay, and question number 2 is find the current through 10 ohm resistance. Where is the 10 ohm resistance? Is between the terminal A and B. Here is the 10 ohm resistance. So current through the 10 ohm resistance. You need to find the current through A and B and draw the final equivalent circuit from Norton's theorem. Okay, so let's check my solution, and if you know the steps to find the Norton's theorem, you can try with your own first. Okay, so let's check. Here is the answer. In a Thevenin's theorem, we know that I previously told you that in the Thevenin's theorem we need to find the VTH, we need to find the RTH, and then the final equivalent circuit. Okay, in the Thevenin's theorem, and in the Norton's theorem we need to find the RTH also. Okay, and the Norton's current. I will tell you how to find the Norton's current. First, we need to calculate the RTH. As we calculate the RTH in the Thevenin's theorem, in the same process we need to calculate the RTH here. Okay, so draw the RTH circuit and then find the RTH current. Okay, so draw the circuit. To calculate the RTH, we need to draw at first the circuit, and I previously told you that we need to eliminate the voltage and current all sources. The voltage sources by the short circuit and the current sources by the open circuit. So here is 2 voltage sources, we need to eliminate it. Okay, so we eliminate the 20 volt by the short circuit here, and we eliminate the 12 volt by the short circuit here. Okay, so it is 5 ohm, it is 2 ohm, and it is 8 ohm. You must need to mention the units ohm. Okay, so here we need to write the RTH, whatever we find RTH here, so no need to calculate the VTH, so RTH. Okay, so what is the RTH? RTH is equals to 5 plus 8 and 2 sorry first we need to saw the diagram from the terminals. Okay, you saw that here is 8, so 8 is in series plus 5 and 2 are in parallel. Okay, so what is the formula of parallel circuit? 5 into 2 by 5 plus 2. So 8 plus 10 by 7, and it is 66 by 7 ohm. You must need to mention the units. So this is the RTH. It is easy, like the previous Thevenin's theorem. Okay, so we calculated the RTH. Now we need to calculate the Norton's current, replacing to the Thevenin's voltage. We are calculating the Thevenin's voltage in the Thevenin's theorem. So not so, means here is no need to calculate the Thevenin's voltage. In the Norton's theorem, we are calculating the Norton's theorem. Here also we need to draw the circuit. Okay, here no need to eliminate the sources. So like the VTH, in the VTH no need to eliminate the sources. So draw the diagram, full diagram. To the terminal A and B. Okay, to calculate the VTH also, we have drawn the full diagram between the AB terminals. Whichever terminal we need to calculate the current. In this question, here is told that the current through the 10 ohm resistance, means 10 ohm is in the AB. Okay, so we need to eliminate that AB circuit, like the VTH circuit. Okay, so draw the circuit 2. Here it is 8, and we are calculating the VTH, calculated the VTH in the Thevenin's theorem, but here we need to calculate the Norton circuit. So we need to add the AB terminals. We need to add the AB terminals by the short circuit. Okay, and through the short circuit, here current passes the IL, means the it is IN, means Norton's current. Okay, so in this circuit the current is flowing, it is IN, and assume that from the source the total current is I. Okay, so in this circuit the current through it is I minus IN. Okay, you understand it, and it is 12. Okay, so now we need to calculate the IN. So how we can calculate the IN? It is simple to applying the Kirchhoff's voltage law, KVL. So applying KVL in the circuit, in the two circuit. At first the small circuit, it is okay, I in the direction, here I is in that direction, here I minus I1 in that direction. So we assume the loop in this clockwise direction. So the loop is in direction clockwise direction, and the voltage and the loop out from the plus side, of the voltage. So it is the plus 20. And previously I told you that if the direction of the loop and the current direction is in the same direction, then it is a minus. Okay, so here it is 2 into I minus in, and it is the minus. And in this 5 ohm, the loop direction and the current direction is same, so it is 5I is equals to 0. So you can calculate it. 20 minus 2I plus 2I Norton's I minus 5I is equals to 0. So it is 2IN minus 7I is equals to minus 20. So it is 7I minus 2IN is equals to 20. Okay, so it is done. It is the first equation. And we need to apply the KVL in this also, in this circuit also. In this circuit we calculate in this circuit, and we need to calculate now in this circuit. Okay, so applying this. So now we are calculating we are applying the KVL in this big loop. Okay, so apply it. So it is IN. So we need to calculate the we need to applying the KVL in this circuit. So here the current direction is this, and also the loop direction what we are assumed is this, so it is same direction. So it is minus 8IN 12. The loop from which the direction outs, the loop outs from which end in the voltage source is the is we taken the sign, it is minus. The loop outs from the minus side, so it is minus also, minus 12. Here is no resistance, and here the current direction is this and the loop direction is this, so the current and loop direction is opposite. So it is plus 2 into I minus IN is equals to 0. So you can calculate that 8IN minus 12 plus 2I minus 2IN is equals to 0, and 2I minus 10IN is equals to 12, and this is the second equation. We need to find the IN. Okay, so we need to find the IN. Previously this equation is occurs, so it is 7I minus 2IN is equals to 20. 7I minus 2IN is equals to 20. Is it right? 7I minus 2IN is equals to 20. Yes, it is right. So from the equation we need to find the IN. Okay, so We can eliminate the in easily. So at that time I eliminate the in. Okay, so here what is it? 2 in. From this we are multiplying the 5, so 5 for the 35 I minus 10 I n is equals to 100. Okay, so write the calculation. 35i minus 10 in, 35i minus 10 in is equals to 100. And what is the second equation? Is 7i minus 2 in. 7i minus, sorry, it is what we multiply actually. Okay, the second equation is 2i minus 10 in is equals to 12. 2i minus 10 in, 2i minus 10 in is equals to 12, is equals to 12. So from this it is plus, it is minus, it is minus. You can calculate the I easily. What is it? 33i is equals to 88. Okay, so I is equals to 8 by 3 ampere. So what is in? In is equals to minus, we put the value of I in this equation. So what is in? In is 10 in is equals to 12 minus 16 but 3. So you can calculate the in. Okay, I am not calculating it. You can calculate the in. So you understand the process of calculating the in. Okay, so in the Norton's theorem you need to first calculate the RTH as the Thevenin's theorem. Second, we need to calculate the AB terminal Norton's current. Whatever is given in between the AB terminals, we need to short circuited it, and the remaining circuit is same as the question. Okay, short circuited this current, and from this AB terminal the current flows is in, means the Norton's current. And whatever process you applied in this question, I applied the KVL to find the in. You can also in many questions you can also apply the current divider rule. Okay, so whatever you feel easy to calculate the in, you can. So I am applying the KVL in this and then in this. So here we get the two equations and find the in. Okay, so and at last what is the question? Draw the final equivalent circuit from the Norton's theorem. What we are calculated, it is RTH and IL. Okay, so you can calculate it, and the final Norton's theorem is like that. it is the IL, and we know that the resistance is always in parallel with the current source, so here it is parallel and it is AB terminal. And in the question here is given in between the AB terminals it is the 10 ohm, so we neglected it, but here we need to join the AB. What is question, whatever is given in the question, it is 10 ohm and it is IL, okay, and it is RTH. In the Thevenin's theorem, what we get, it is VTH and RTH is series, because we know that the resistance is always in series with the voltage source, and it is the whatever is constant given, it is that resistance. Okay, so in the Norton's, the final equivalent circuit is like this. It is the IL, RTH is parallel with IL, and it is whatever in the question is given. Here is 10 ohm. So I am erasing this Thevenin's. Okay, so here it is the final equivalent circuit. So from the Norton's, it is question number 1, and find, in this question here it is find the I. And one more thing, that I am assuming the Norton's direction in this direction. Okay, so I am assuming the Norton's in this direction. Okay, in this direction. So if the final Norton's value is positive, so it means we assuming in the correct direction, but it is, if it is minus, so the Norton's direction is this. Okay, means whatever you choose the direction of Norton's, if it is positive then it's okay, but if it is negative, then whatever you choose the direction in the Norton's, it is just positive or nothing. Okay, so we are assuming the Norton's in this direction, so we get, I think, positive. So in the current source, sorry, it is IN, in the current source it is this direction. Okay, so you can, I think you can understand it. And finally we need to calculate the I from A to B. The total current is IN in this circuit. Total current is IN. So simply we are applying the current divider rule. What is it? IN is the total current into the current through which resistance whatever it is parallel with. So from the 10 ohm resistance the I is flowing, so RTH is in parallel with 10 ohm, you can see that. So here it is RTH, and in the lower portion it is RTH, the parallel portion, and what resistance is in the I, the I flowing through whatever resistance. So it is 10, here it is 10, so it is 10. You put the values of RTH and IN, then you can find the I, and it is our question number 2. Okay, so I think you understands the steps to calculate the Norton's current, and then the final Norton's. I think you can draw the final Norton's circuit now. In the next lecture, I'll discuss about the two problems, and I think if you have any doubt in this lecture, you can ask me in the comment section, and you can ask me also in the Instagram handle. I will given in the comment. I will given in the description box. And if you like the videos, please like to the videos and subs to our channel. It's really motivating for us. And then it is for today. See ya. Have a good day.